All right, let's talk about the candidates test. So we looked at the candidates test from 3 points of view: a function, a graph, and a table of values. So on this function, it didn't transfer over very well when I cut and pasted it from that document. Here's the function. I found the first derivative. I factored out a 6, and then I factored into x minus 2 and x plus 1, making candidates for having a maximum or minimum value at x equals 2 and x equals negative 1. Here's my candidates test. Notice that I've got my endpoints, negative 2 and 3, as well as my zeros. So remember that when you're using the candidates test, you want to take these candidates and plug them into the original function. So negative 2 gives me a negative 4. Negative 1 gives me 7, 2 gives me negative 20, 3 is going to give me also something really negative. I'm looking for a maximum value. So of these candidates, 7 is the largest, making my maximum value 7 at x equals negative 1. All right, this graph is next. Stop. What's the picture a picture of? It's a picture of the derivative of the function f. So what we want to know is, where does a minimum value exist? At 0, 1, 2, 3, or 5. So this is like multiple choice. So your candidates will be your endpoints of the interval, so 0 and 5. And then our other candidates will be wherever the original function has a horizontal tangent, or remember, those maximum and minimums on the original function will be pulled down or up to the x-axis and become zeros on the graph of the first derivative. So because this is the graph of the first derivative, those horizontal tangents of the original function were 0, and they happened at 1 and 3 because 1 and 3 became zeros of the derivatives graph. So then I can't really say anything about 0 and 5. I just have too little information. Then I'm going to consider 1 and 3 to be where my minimum value exists. As I look at number 1, as I look at x equals 1, I go from negative to positive. So I go from negative to positive. Look at this graph down here. This is an example of the graph of the original function, where I was a negative slope and then a positive slope. So I went from decreasing to increasing. That's where my graph was concave up. So negative to positive on the derivative, negative slope to positive slope on the original function. That must have been a minimum. And then when I consider the point x equals 3, I don't have enough information here. I'm not going to use that one because I have a plus and a plus there. All right, so that's all I'm going to say about that one. So I would choose B. That's where I think a minimum value exists. And then finally, this tabular example. So f of x, remember, will have zero tangents at x equals 2 because that's where the derivative is equal to 0. For your candidates test, use your first and last points on your interval, 0 and 8, the endpoints. Use wherever you have a 0 slope, so 0 slope, first derivative. And then to come up with your function values, that's pretty easy. You just find f of 0, which was negative 3, f of 8, which was, that should have been a 3. Whoopsie, that should have been a 3. And then f of 2 is going to be 5. So anyway, I'm going to go with 5. I just shouldn't have written that 9 there. So the correct answer is not not x equals 8. It should be x equals 2 because I'd have a maximum value of 5. All right, so I'm not going to re-record this. Just forget about this. Remember, 8's function value is 3. 5 is going to be larger than 3. So, anyway, you get the idea. Candidates test, check your endpoints, check where you're going to have a 0 tangent, horizontal tangent. That's where you have a 0 on the first derivative. All right, thanks, guys.